Okay, Jane, here's some help with problem number 10C. If you remember, we found y prime for part A was this expression right here. We also found the two tangent lines at the points in the curve where the x-coordinate was 1, and here was an indication of that. We found the points to be 1, 3, and 1, negative 2. And then we wrote the two tangent line equations, y equals 3 and y plus 2 equals 2 times the quantity x minus 1. So that's a quick review. And then we were looking at part C, find the x-coordinate of each point in the curve where the tangent line is vertical. And the tangent line is vertical when the denominator of the first derivative, is 0. See if I can circle that again. Or y prime is undefined. If we can find a point on the curve where y prime is undefined, it has to have a vertical tangent line. So here I am setting that denominator equal to 0, and since it asks for the x-coordinate, I'm going to try to solve for x. The first thing I did was factor out an x from each term, and then using the zero product property, I set this factor equal to 0, or this factor equal to 0. Now, if I try to plug x equals 0 back into the original equation, I get 0 equals 6, which is not ever true. So this really is not an x-coordinate of a point on the curve. 0 is not in the domain of this function. But if 2y minus x squared equals 0, it must be true that y equals x squared over 2. So what I want to try to do is find the x-coordinate of a point where y equals x squared over 2. Because if that proves to be the case, this denominator will be 0. So I'm going to substitute x squared over 2 in for y into this equation right here, which is what I did right here. Wherever there's a y, I replaced it with x squared over 2. I get x to the 5th over 4 minus x to the 5th over 2 equals 6. I multiply every term by 4 to clear the equation of fractions, which results in this. Combine the similar terms, multiply both sides by -1, and take the 5th root of both sides. And I get x equals the 5th root of -24. And then I went over to Desmos and graphed the line x equals the 5th root of -24, which is this blue line right here. And indeed, that looks like a tangent line, and of course it is vertical because it's x equals a constant. So there is the x-coordinate of a point on the curve where there's a vertical tangent line. We could go to the trouble of putting this value for x back into the original function and solving for y, but that would prove to be fairly tedious. It could be done because you'd have a quadratic equation in terms of y, but you'd have funky coefficients, 5th root of -24 and -24 to the 3/5 power would be one of the coefficients of the quadratic equation. So there you go. I'll end this video, send it along, and I'll look at the other two problems.